Morning class. So the video which I uploaded yesterday, in that we have started the chapter that is the last part of our syllabus, that is non-steroidal anti-inflammatory agents. Okay, so analgesics, they are generally classified into two types, that is the opioid analgesics and non-opioid analgesics. In the opioid analgesics, we have seen the morphine, heroin, codeine like this, which are derivative comes under the morphine. And second one, the non-morphine, or you can say the non-opioid analgesic, in that non-steroidal anti-inflammatory drugs comes. Okay, so it is called as non-steroidal anti-inflammatory drug, that is the NSAID. Okay, so what is NSAID? I will just go over this part that is already have share a video in that detail it is given. So this is the class of drug. It can relieve the pain, reduces the inflammation. Inflammation means redness and the swelling of the parts, and bring down the high temperature. Okay, so if you see the paracetamol, it is the non-steroidal anti-inflammatory agent. So this paracetamol is useful to lower the fever or the high temperature to the normal temperature. So that is, they bring down the high temperature. That is they are useful for the treatment of fever. They are also useful for the reduction of inflammation, and they can relieve the pain. At least they can act as the analgesic. So they are anti-inflammatory along with the antipyretic and the analgesic. So they are useful for the treatment of wide range of conditions like headache, toothaches, sprains, pain in the periods. Okay, then for the treatment of common cold or the flu, inflammation, arthritis. So in different these, they can be useful as a non-steroidal anti-inflammatory agents. Okay, so they are generally work by the blocking the production of prostaglandin, which is the chemical messenger. It is responsible for the pain and swelling in the inflammatory conditions or in case of inflammation. So their inhibition of prostaglandin, or they inhibit the synthesis of prostaglandin, which is responsible to produce the pain and the swelling of or the inflammation condition. Okay. So in case of MAO, that is the mechanism of action, we find out that the prostaglandins, they are the mediators of inflammation. So inflammation is the natural response. So तुमच्या बॉडीमध्ये एखादा बॅक्टेरिया किंवा व्हायरल इन्फेक्शन झालं तुमच्या बॉडीमध्ये, तर पहिलं तुमचं इंडिकेशन आहे, दॅट इज इट प्रोड्युसेस द fevers किंवा inflammation. So that is the natural response. That means you any foreign particle, it enters in our body, and our body is fighting against that foreign particles. So inflammation is the natural response that occurs immediately following any tissue damage. So these drugs, that is the non-steroidal anti-inflammatory drugs, they are generally the irreversible inhibitors of cyclooxygenates. Okay, so this cyclooxygenase is responsible for the formation of prostaglandin. So if we inhibit the cyclooxygenase, the prostaglandin will not synthesize, and if it will not synthesize, there is no inflammation, or the sign of symptoms of inflammation can be reduced. Okay, so that is the main mechanism of action of non-steroidal anti-inflammatory agents. So these prostaglandins, these are the family of chemicals that produced by the cell of body in response to the illness or injury. Okay, so they generally promote inflammation, pain, as well as the fever. They support the blood clotting function of platelet and protect the lining of stomach from the acid. Okay, so in antacid we have seen prostaglandin is there, so they are responsible to protect the lining of stomach from the effects of acids. So what is COX-2? So this cyclooxygenase, they are of generally two types, which are of interest, that is the COX-1 and COX-2. So selective COX-1 or the selective COX-2 means which inhibit work as a non-steroidal anti-inflammatory by blocking only the COX-2. It will not act on COX-1. So when the blocking of this enzyme, that is the COX-2 cyclooxygenase, is inhibited, then what happens? the production of prostaglandin is prevented. And when the production of prostaglandin it is prevented, it results into the reduction of pain, reduction of swelling, because they selectively block the COX emitter. So the traditional anti-inflammatory drugs such as aspirin, inflammatory is reduced by blocking the COX-2. But the protective mucous lining of stomach is also reduced because COX-1 is blocked, and which is responsible for the which results into the formation of a stomach upset, ulceration, or bleeding from the stomach and intestine. So what it tells? So what is the function of prostaglandin? So prostaglandin is responsible to maintain the lining of stomach. Okay? So here you can see they protect the lining of stomach from the effect of acid. And when we are giving the COX inhibitor, so there are two types of COX inhibitor, COX-1 and COX-2. So when COX-2 inhibitor is present, it produces proper anti-inflammatory effect, analgesic effect. But when such as the non-selective drugs, such as the aspirin, which are traditionally used, so along with the COX-2, they are also responsible to inhibit the COX-1. And this COX-1 is mainly responsible for the maintaining the lining of the stomach. So COX-1 is responsible to maintain the lining of the stomach, that is the protective part in the stomach along with the wall. And if along with protective mucus, okay, so if COX-1 is inhibited, the so along with the anti-inflammatory activity, it also reduces the lining of the mucus lining, which is responsible to protect the stomach. Okay, so it will result into the decrease in the lining, and if decrease in the lining takes place, we can form stomach upset, ulceration, and bleeding from the stomach and intestine. So most of the person, you see that if they are consuming the aspirin, so they are probably getting the side effects like stomach upset. So why stomach upset takes place? Due to the they are non-selective. So along with the COX-2, they are also inhibit the COX-1, and when COX-1 is inhibited, what happens? The lining of the stomach decreases, and when the lining of stomach decreases, the side effects like stomach upset, bleeding, ulceration, it can be produces. So it is generally said that don't take these drugs for the normal condition. If any extreme condition is there, you can easily consume this drug. But when it is only normal condition like headache, so if you consume this drug, so along with the COX-2, they are also responsible to inhibit the COX-1, and it will reduces the lining of the stomach. So it may result into the ulcer as well as the bleeding from the stomach along with the stomach upset. Generally, what happens in the body? Arachidonic acid is present. From arachidonic acid, prostaglandins, that is the thromboxane A2 and prostaglandins, prostacyclins. Okay, so they can be synthesized from the arachidonic acid. So through COX-1, they form this part. Through COX-2, they are formed this part. Okay, so when arachidonic acid is converted into thromboxane or the prostaglandins through COX-1, they are responsible for the performing this type of physical functions. When they bind to the COX-2, so due to the COX-2, they produces the inflammation, pain, and fever. So along with that, they can produce the renal function, vasodilation, platelet aggregation, mucosal integrity, ulcer healing. So such conditions can be introduced. Okay, so if COX-1 is inhibited and COX-2 is inhibited, then there is no synthesis of prostaglandin. And if prostaglandin is not synthesized, it will not produce the conditions like inflammation, pain, and fever. So if COX inhibitors are given, which are not responsible or which is responsible to inhibit the prostaglandin synthesis, there is no synthesis of prostaglandin. So it will result into the anti-inflammatory, antipyretic along with the analgesic effect. What are the examples of these anti-inflammatory agents? That is aspirin. So this is the structure of aspirin. Okay, it is also called as acetyl salicylic acid. So this is the benzoic acid. So this is the benzoic acid, and here acetoxic group is present. So it is called as 2-acetoxy-benzoic acid. The other example is the diclofenac. This is the structure of diclofenac. So two chlorine groups are present, so dichloro, it is called as a diclofenac. Then endomethacin, this is structure of endomethacin. It is of the acetic acid derivatives. What we have seen in the last uploaded video, it produces the, or it having the acetic acid derivatives. Next one, ibuprofen, ketoprofen, then paracetamol. Okay, this is the structure of paracetamol. Para position la amino group. So it is called as paracetamol. Mefenamic acid, you can see it is having the acid, so it is also the acidic derivative. So it is generally amino acidic derivative. Then nabumetone, naproxen, phenylbutazone, celecoxib, piroxicam. The other structure is aspirin, diclofenac, endomethacin, ibuprofen. This is ibuprofen name. This is ibuprofen name for paracetamol. This is for ketoprofen. This is for mefenamic acid. Then nabumetone, naproxen, phenylbutazone, piroxicam, celecoxib. Then we move to the next part, from introduction to the classification of non-steroidal anti-inflammatory agents. So generally they are the COX inhibitors. So selective COX inhibitors, these are the celecoxib and rofecoxib. So ज्यामध्ये तुम्हाला कॉक्सिब हा फायनली मिळणारा शब्द असेल, ते ड्रग हे सिलेक्टिव्ह कॉक्स 2 इनहिबिटर्स असतात. देन नॉन सिलेक्टिव्ह मध्ये सॅलिसिलिक ऍसिड डेरिव्हेटिव्ह सॅलिसिलेट, दॅट इज द ॲस्पिरिन, propionic acid derivative, that is the ibuprofen, ketoprofen. Okay, so ketoprofen मध्ये propionic acid आहे 1 2 3, so 3 carbon with acid, that is the propionic acid. Then acetic acid, that is the diclofenac and aceclofenac derivative. Phenemic acid, that is the mefenamic acid. Pyrrole derivatives, that is the ketorolac. Then oxycam derivatives, that is piroxicam, meloxicam. Then indole derivatives, sulindac, indomethacin. Pyroxenol derivatives, that is the phenylbutazone. These are the selective drugs. Then nimesulide, meloxicam, nabumetone, these are the selective COX inhibitor. And the drug paracetamol, it having the greater analgesic activity, greater antipyretic activity, but weak anti-inflammatory activity. So it having the poor anti-inflammatory activity. So this is the classification of non-steroidal anti-inflammatory agents. So we start with the first drug. These are the salicylic derivatives. Okay, so these derivatives, they are derived from salicylic acid. So this is salicylic acid, where benzene is consists of COH and OH. Okay, so 2-hydroxybenzoic acid, this is called as salicylic acid. So this salicylic acid and its derivatives, they are responsible to inhibit the prostaglandin and other mediators which are responsible for the inflammation and act as an anti-inflammatory, antipyretic and analgesic agents. So this is acetyl salicylic, that is acetyl salicylic acid, which is the aspirin, which is the example of salicylic derivatives, which comes under the non-steroidal anti-inflammatory salicylic acid. So example is aspirin, so chemical name is acetyl salicylic acid. So here we can found acetyl group is there, this is salicylic acid, so acetyl salicylic acid, this is the chemical name for the aspirin. So in the market it is present in the form brand, under the brand name, that is the aspirin. So it acts as an anti-inflammatory, antipyretic as well as the analgesic agent. So it comes under the chemical class, that is the salicylic acid derivatives. Okay, the structure activity relationship for these salicylic acid or the salicylic acid derivatives. For optimal activity, acetyl group is necessary, which must be present at the second position. So here acetyl group is present, so it must be present at the second position. So instead of this, if it is present in third or fourth position or this position, it will reduces or it will decreases the activity. So this acetyl group, it must be present at the second position. Then increase the carbon chain of acetyl group, it will decrease the activity. So there must be presence of acetyl group. So here you can find that here only one CH3 is there, that is the CH3CO. If we increases the CH3, it is converted into CH2 CH3 or propyl group. That means if we increase the number of carbon in the acetyl group, it will decreases the activity. So first part, there must be present of acetyl group at second position. Second one, there must be a acetyl group. If its chain length increases or the number of carbons in the acetyl group it increases, it will decreases the activity. Then third one, if carboxylic acid is replaced by ester group, its activity will increase. Okay, so here if acid group is present, if it is converted into ester group, its activity will decrease. Then attachment of any substitution at 4 position, then the activity will loss. So this is second position, this is third, this is fourth. So at the para position, if any substitution is present, the activity of aspirin or the pharmacological activity of aspirin, it will lose. If we attach a halogen ring, halogen group to the aspirin or any salicylic acid, then it will increases the activity. But as we know that if we attach the halogen, its toxicity is also increases. So if halogen atom is there, its toxicity increases. So better not to attach the halogen group. The removal of hydroxy group from salicylic acid results in benzoic acid, that is the less active. So here in salicylic acid, if this hydroxy group is removed, so here there is only the benzoic acid is present. So it is active, but it is less active as compared to the salicylic acid. So these are the points which comes under the SR of salicylic. First one, at the second position, there must be presence of acetyl group. If it is present at third or fourth position, it will decrease the activity. Then the acetyl group consists of a single CH3 group. If this CH3 group or the length of that CH3, it will increases, the activity will decrease. Third, the carboxylic acid which is present, if it is converted into ester form, then its activity will decrease. Then any attachment at fourth position, that is this position at the para position, then its activity will lose. Then halogen substitution, it will give better activity, but along with the activity, it will also increases the toxicity. And finally, if we remove the hydroxy group, it results into the only benzoic acid. This benzoic acid is having activity, but it is less active as compared to the other salicylic acid derivatives. Now from aspirin, that is the salicylic acid derivative, we will move to the next drug, that is the drug paracetamol. So this is paracetamol. Okay, in acetyl para aminophenol. So it is the acetaminophen, or you can say it is the paracetamol. Okay, so it is also called as 4-acetamide phenol or acetaminophen. Brand name Calpol, Panadol, these are the brand names. They are used as antipyretic analgesic. So among these drugs, the paracetamol having very weak or it does not having any kind of anti-inflammatory activity. So it is given paracetamol only as an analgesic and antipyretic. Chemical class para-aminophenol derivatives. So under these phenol derivatives or para-aminophenol derivatives, there are two examples are there. One is the phenacetine, second one is the acetaminophenol, that is the paracetamol. It is the active metabolite of phenacetin. Okay, so if you observe here, OC2H5 is present. When O-deethylation takes place, this OC2H5 it is converted into hydroxy group. So this phenacetin, when it undergo metabolism, it is converted into drug that is the paracetamol, that is the acetaminophenol. So in vivo, when drug given phenacetin, it is converted into acetaminophen, that is the drug. So phenacetamin is no longer available in the market. Then the paracetamol is effective as analgesic and antipyretic. It is not given as the anti-inflammatory drug. It is due to the weak inhibition of cyclooxygenase. It is the weak inhibition prostaglandin synthesis. Then ACR of paracetamol. Acetyl group must be present for the optimal activity of paracetamol. So here we can observe that acetyl group is present. It is necessary for the optimal activity of paracetamol. Then no substitution should be present at number 4, 5 and 6. So this is 2, 4, 5. If any substitution is present, it will decreases the activity, and the replacement of phenolic group with ethoxy group, it will result into the formation of metabolite, which is the more toxic. Okay, so these are some important parts regarding the SAR of paracetamol. So next one is the pyrazolone and pyrazolidine derivatives. So example of aminopuron, K-butazole and antipyrin. So these drugs are not there for our syllabus, so we are escaping these drugs. The next drug is the mefenamic acid. So this mefenamic acid comes under the derivative of N-ethanoic acid derivative, that is the phenamate derivative. So here you can observe COOH. If NH2 is present here, it is ethanoic acid, but it consists of its derivatives. So one of the hydrogen is replaced by another group, so it is called as N-aryl ethanoic acid derivatives or phenamate derivatives. So these have no advantages over non-steroidal anti-inflammatory, but frequently they cause side effects such as diarrhea. Okay, so example is mefenamic acid. So it is the anti-inflammatory and the painkiller. It is used to treat the conditions like arthritis or the pain associated with the menstrual bleeding and pain after surgical operation. So it is the competitive inhibitor of both COX-1 as well as the COX-2, which are responsible for the inhibition of prostaglandin biosynthesis. Okay, so the mefenamic acid is generally used as the anti-inflammatory and painkiller. The next class of a drug, that is the heteroaryl acetic acid as well as the propionic acid, that is the acid containing non-steroidal anti-inflammatory. So it is the important class of the NSAID according to aryl as well as the heteroaryl acetic acid derivatives. They are generally used are for the treatment of pain which arises during the rheumatoid arthritis. Okay, so these are comes under the indole acetic acid derivatives, propionic acid derivatives, heteroaryl acetic acid, enolic acid, and alkanol, that is the example nabumetol. So these drugs comes under these heterocyclic acetic acid and propionic acid derivatives. So in that we'll move to the first drug, that is the indomethacin. Okay, so this is the structure of indomethacin. So they are used as analgesic, anti-inflammatory, as well as they are useful in the treatment of gout. They are useful to reduce the fever, pain, stiffness, as well as the swelling. The addition of hydroxy group at the ortho meta positions it will reduces the activity. Okay, so this is about the drug endomethacin. Okay, this is the structural activity relationship of drug endomethacin. So it is the important part in the exam, generally asking the SAR of the endomethacin, or the give the substitution which increases the activity, or the substitution which will decreases the activity. So like which they are asking the indirect question or direct question, give the SAR of non-steroidal anti-inflammatory drug, that is the endomethacin. Okay, so we will start with this part. So this CH2 group which is present in the structure is more active than phenyl. So in CH3 group, so this CH3 group, if we replace with the phenyl ring, then the activity will decreases. So the CH3 group which is present at that position, it will increases the activity. Then here COH group is present, so replacement with other acidic, it will decreases the activity. So the acid has, if aromatic acids if apply, or more other acidic functions are substituted, then the activity will decrease. But if its acidity is more, its activity also increases. So instead of COH, if we attach amide group, then also the drug becomes, or the activity of it decreases, or drug becomes inactive. Okay, then the CH2 which is present at this position, okay, this is CH2. So branching of this CH2 does not alter the activity. So we can branch the CH2 group, or we will keep the CH2 group as it is. It will not alter the activity. Then this OCH3 group, it is very flexible position, as it can be replaced by halogen, it can be replaced by acetyl, it can be replaced by amide, it can be replaced by CH3 group. It will does not changes generally the activity. So they are produces the active drugs. Then this nitrogen, regarding this nitrogen, it is not essential for the activity of C version. So in, if it is converted into C, it becomes the Indian analogs. For example, Sulindac. So he actually indole रिंग आहे, बरोबर आहे. सो इंडोल रिंग मधलं जर नायट्रोजन काढलं आणि फक्त तिथं कार्बन न रिप्लेस केलं, ओके, सो ही रिंग असेल, it becomes the Indian ring, INDENE, Indian ring, which is present in the Sulindac. It also having the similar kind of activity. So if nitrogen is present, it becomes indole. If it is replaced by the carbon, it becomes Indian. So it does not alter the activity. So the activity remains as it is. Next part, here these substitutions, N benzoyl with alkyl or alkyl gas, it will decrease the activity. But if para position ला chlorine असेल, इलेक्ट्रॉन विड्रॉइंग ग्रुप असेल इथं क्लोरीनला, सो क्लोरीन असेल किंवा फ्लोरीन असेल किंवा CF3 असेल, the activity of drug remain as it is. Okay, so that is the structural activity relationship of a drug endomethacin. Okay, so this CH3 is more active than phenyl. then CH4 ची जेवढी ऍसिडिटी वाढेल तर तेवढा ऍक्टिव्ह असतो. दुसरे ऍसिडिक ग्रुप असेल, ऍक्टिव्हिटी डिक्रीज होणार. तिथं जर अमाइड लावलं, ऍक्टिव्हिटी डिक्रीज होणार किंवा ड्रग इनऍक्टिव्ह होणार. इथं जे CH2 it can be branch or it can be without branch, it will not affect the activity. Then this OCH3, it is flexible group. If flexible position, it can be uh, present in the form of methyl group or amine group or halogen acetyl group. It does not alter the activity, so the drug becomes active. This nitrogen which is present, if it is in, it is indole, it also having the activity, but it is not necessary for the activity. This nitrogen, if we replace with the carbon, the drug becomes indene. the example Sulindac, which is also the non-steroidal anti-inflammatory agents. And this part here, halogen Cl is present, so it can be fluorine, it can be trifluoromethane, it can be parachlorine. It will not alter the activity, but replacement of N-benzoyl with alkanoyl or ara-alkanyl group, it will decreases the activity. So this is about the SAR of drug endomethacin. The next drug is the propionic acid derivatives. Okay, so aryl propionic acid derivatives are effective as in a CID. They are having the advantages over aspirins and endomethacins. They are better tolerated and they are share all the features of all NSAID. For example, ibuprofen and naproxen. These are there for our syllabus. So here they consist of CH3 central C this is a 3 carbon with acidic group. So it is propionic acid. So it is propionic acid derivative. Similarly, you can observe here CH3 CH2COH, that is the propionic acid derivative. So ibuprofen, ketoprofen, chlorbiprofen, naproxen. These are the propionic acid derivatives. Okay, so ibuprofen was the first member of propionic acid class in the general use. It consists of the isomer. So here you can observe this carbon. So this carbon having CH3 group at one side, COH group, this heterocyclic, so this aromatic ring, and here hydrogen is present. So due to the presence of four carbons, this becomes asymmetric center. And when it becomes asymmetric center, it produces the isomer. So it produces S isomer and R isomer. So in case of ibuprofen, the S isomer is more active as compared to the R isomer. The naproxen is one of the most widely used NSAID. Okay, so SAR of ibuprofen here, carbon is present. Okay, so S isomer, better activity. Then here aromatic group is present. It may be replaced by any aryl or heterocyclic group. Then here substitutions, it may be fluorine and chlorine. Then it shows the better activity. So this is the short SAR regarding the ibuprofen. Next drug, it is the heterocyclic heteroaryl acetic acid derivative, that is the diclofenac. So here acetic acid is present. It is heteroaryl acetic acid. So diclofenac belongs to the group called as NSAID that are used for the treatment of moderate pain to the mild to the moderate pain, fever, as well as the inflammation.